Hi, I'm Alistair, I'm a games designer, and in this video I'd like to describe an escape room puzzle based around the idea of CCTV camera footage. Now, lots of escape room games use real CCTV cameras so that games masters can monitor what players are doing in the room. But here I'm talking about a fake CCTV camera app that players themselves use to review pre-recorded video footage made to look like a CCTV feed. And there's lots of different puzzles you could create based around this idea. For example, maybe players need to switch between different video feeds to track the movement of an actor that was recorded moving around the space. And as they switched to the different video feeds, they could listen in on a conversation they were having as they moved around. Or perhaps players also find a floor plan or layout of the space complete with the locations of each of the CCTV cameras. If they do that, they can work out the path that the actor must have taken and either the destination they were travelling to, or maybe that path spells out a digit or a letter for them as part of a code. Perhaps the location shown in the CCTV footage is actually the same room in which the players themselves are in. And that means maybe they'll watch someone giving away the location of a secret panel on a wall, or entering a combination into a safe or a padlock that they can enter into that same lock in the room themselves. And of course, if players are led to believe that they are reviewing existing CCTV footage, it makes sense that they could scrub to a particular point in a timeline to see when an event happened. Perhaps the timestamp of that event is relevant as well to solve a puzzle. So there's really lots of different ways you can use and customise this kind of idea. And what I really like about it, especially given in mind the current climate in which there's more lockdowns happening over the world, is that it can be used in real life escape room game just as easily as it can in an online game played in the browser instead. So, all the footage you've seen so far was taken directly from an application I made using Unity. And Unity is a game development engine. You can download it for free from unity3d.com. I'm using the latest version, which is 2021.1.23, but I'm not actually using any particularly recent features. So long as you've got a version that's been released in the last few years or so, you should be able to follow this guide exactly the same way. And I've used Unity a couple of times in previous tutorials, so if you've seen any of my other recent projects, this might look familiar to you already, but if not, I'll try to describe as I go the way that this project is set up, and hopefully it'll make sense to you. So the way I always think of using Unity is with an analogy to a film. So imagine yourself as a movie director, and you've got the scene in front of you, and what you need to do is to place your actors and your props and all your backdrops and scenery into the scene, and then you need to tell them what to do by giving them a script. And that's exactly the same way that it works in Unity. So we start off looking at the scene view here, and this is the image that we see. You can see various things here, and in the hierarchy of our scene, at the top level, you can see we've got three components. We've got a main camera, and that's going to be responsible for determining what is actually displayed on the screen to the user. We've got an event system. That's going to be responsible for reacting to inputs. So when the player clicks on a button, or when they drag this slider or something like that. And then we've got the canvas. And the canvas is like a 2D backdrop onto which all of the other components are going to be arranged. So on our canvas here, we've given it a script. Now this is a script called a canvas scaler, And this is one of the scripts that's built into Unity. And what this does is it will resize the canvas and all of the components it contains when the screen resizes. Now this is useful because one of the benefits of Unity is it lets you target lots and lots of different devices. So you can build this same application. I can build for a Windows PC or a Linux PC, a Mac, or an iPad, an Android tablet, a mobile phone, an Xbox, whatever. And in fact, there's a simulator here that will let me view how it will appear on different devices. Now, again, if you have got experience of developing for the web, for example, then you'll know that one of the headaches is that different devices can display the same page in different ways because they have different aspect ratios and everything else. And you'll see here, I select different devices, you can actually see how my canvas scaler is resizing the elements to try to fit in based on different height and width ratios of devices. Now see, actually as it happens, I need to do a little bit of work here. If I wanted to target the Xiaomi Mi A3, my buttons are being slightly cut off in the corners here. But I actually don't want to do that in this case because I'm imagining this being used on a desktop PC with a 16:9 aspect ratio. But I'm just sort of demonstrating that this is quite a useful feature, and that's why I've got this canvas scaler script on my canvas element here. But if we go back to the scene view here and expand the canvas, you'll see that this has got 3 elements in it. It's got a left panel, a right panel, and a bottom panel. And all these are 4. These don't have any function. They're just letting me arrange elements on the screen in a way that I think makes sense. And it's totally arbitrary the way I've done that. If I wanted my bottom panel to be at the top, I can literally just drag it around like that. I can resize them or scale them or crop them. I could rotate my elements like this. And you can also type exact values onto the inspector over this side here. So if you want to line up elements on the screen, you can do it like that. I'll be totally honest, I'm not much of a designer. I'm sure you can do a better job than me in terms of making this look attractive, but I thought that this looked like a kind of a reasonable setup for an interface to have the controls on the right hand side, my main panel here on the left, and then the slider at the bottom. But you can literally just drag and drop and change these as you see fit if you've got a better design, basically. If I go into my left panel then, so this is the one that fills the majority of the screen space on the left hand side here, and that has got a single actor in it, if you want to think like that, which is this video actor here. So what scripts has video got assigned to it to tell it what to do? Well, it's got 2 important scripts, and again they're both built into Unity, so I haven't had to code anything myself yet. I'm just using all built-in functions. It's got a video player component, and it's also got a raw image component. So to explain how this works, let's start with the video player component. So this is responsible for loading a video clip file, so an MP4 file, for example, or a WMV or whatever, and it's going to play that video based on the settings here. So we can either get it to automatically play when the application starts, and we can get it to loop. If the frame rate drops and it skips a frame, should it catch up with where it was by skipping frames? We can change the speed at which frames are played. So this is kind of, imagine it a little bit like a film projector. This is responsible for actually loading the video clip and playing it. Now it says here at the moment that the video clip is going to play is missing. Now don't worry about that, because the clip that is going to be shown in this window here is going to depend on which camera feed we have clicked. So that's going to actually be set in runtime while the application is running. So don't worry too much about that at the moment. What's important though is this render mode and texture at the bottom here. So again, imagine this is a film projector. It needs to project the frames of this video clip onto something. And if we wanted to make a full screen video application, the easiest way to do that would probably be to render the frames of the film directly onto the camera. So we'd choose camera near plane, for example. That would fill the whole screen with the frames of this clip as the video player ran through them. But that's not what we want in this case. We want to actually have multiple video clips positioned in different positions of the screen, and we want to be able to arrange those video clips just as if we were arranging icons or images or text or anything else on the page. So the way we do that is we tell the video player, the video projector, to render the frames onto what's called a render texture. So a render texture, much like any other sort of texture, so like a JPEG image or like a GIF image or something like that, except it's a dynamic image that we can actually write to as the application runs. And you'll see in my textures window at the bottom here, this is the main render texture which I'm going to be writing to. I've chosen the size it's going to be, and when this video player runs, what it's going to do is it's going to render the frames from whatever video clip has been assigned, and that's based on what camera button we've chosen. It's going to write those frames to this texture, and then the image component that we've got assigned to this component here, well, that is going to display that texture there. So raw image here, this is just like any other image that you can arrange on the page. So let's say you've got an icon here, or some kind of background texture or something like that. The only difference is instead of it being a static sprite, it is this dynamically changing render texture, and that's what's going to display the film in this big area here. Okay, so that might seem a little bit convoluted way of doing it. Hopefully that made sense with the combination of these two components, with this one to play the video clip and to write its frames to a texture, and then this one's actually going to display that texture on our canvas as part of this element here that's in our scene, and that's what's going to make them appear in this part of the application here. Okay, so that's our left panel. Now if we go to the right panel here, we've got a couple of different components here. We've got our 4 sources from our different camera feeds that we can click on, and we've also got some buttons at the bottom here which are our playback controls. Now when I was looking at the main panel on the left hand side here, I sort of said you can drag this around and reposition it and things like that. Now on the right hand side here, I didn't want to have to manually position these elements and kind of drag them up. So what I did was I put on something called a grid layout group on the parent element here. And what that does is it means that any of the children under that parent element will be automatically positioned based on the rules in this script here. So imagine this is like this is your stage manager or something like that. We're the director at the top of the scene here. We've told the camera what to point at. We've arranged the actors on the stage, and then in here we've assigned a component which is a sort of a sub-level layout. So rather than positioning these buttons individually by dragging them up and down, which I can't do, what I can do is change the rules of the layout component on their parent element, and that's going to arrange them separately. So for example, I could make these all a smaller size. Let's make them 150 instead wide, and then say it's arranged them into a 2x2 grid. Or I could change them to back this way, and let's say I want to arrange them in a different order. So let's start at the sorry, not that one. Let us arrange them at the upper left of each box, or the middle right, or wherever you can flex these around. And it's just a way of preventing you having to manually position all these elements. When you want to have a regular arrangement of patterns, which you often want to have in a user interface, this grid layout group is a useful button to have there. And then that's got 4 buttons underneath it, which represent the 4 different camera feeds we can select from. And these are all duplicate copies of each other, so they've all got a button that has a video player and a text component in it, and the button has a script on it called button. Again, this is built into Unity. This is nothing I've written yet. And the button has an event called onClick. And what this does is this is going to call a script when this button is clicked. And you'll see that all my buttons actually call exactly the same script. The only difference is that they pass a different parameter value here. So my top button calls the set source function on the controller object, and it passes the value 0. And here I've got the value 1, 2, and 3. And this controller script, which I'll look at in a moment, this is going to be responsible for changing the source clip that is loaded into this main window here based on the value of the button that was clicked. So remember when I showed you the left panel here and I said don't worry about the fact that this says missing video clip because we'll get that populated in a minute. These are the buttons that are going to do it based on what number was sent there. They also have their own video players here and their own raw image. So this is using exactly the same method as we were using in the main screen here, except that instead of using this render texture.main here, we've actually got 4 different render textures which are assigned to the 4 different raw images here. So I've got render texture 1 on the top one, I've got render texture 2, render texture 3, and these are smaller textures. So this is just a 300 by 180 size texture here. So that's going to be a preview image, and making them smaller should make them render quicker and just make the application a bit more responsive. My main render texture, like I said, is a bigger size texture, which is going to give us high resolution in the main window here. So that's the buttons that set the source of the main window. Close that up, and then we've got our playback controls here. Again, I'm using a grid layout group here just to arrange these 2 buttons in a neat order like this. And my play button is going to call a function called play on the controller. And my pause button, surprise, surprise, is going to call a function called pause. So all of our source buttons here are set to call this function here. And we've got a play button and our stop button. They don't need to pass parameters, so they don't have a value here. They're literally just calling different methods here. And that's essentially how you wire up this idea of what actors are going to do in the scene. You can assign scripts to them that change their behavior, and then if there's a behavior you want that isn't one of the built-in behaviors, such as button or image or video player, then you call your own script instead, and that's what we've done here. So I'll show you what that's going to do in a moment. But the final actor that we've placed on our scene is in the bottom panel. And we've got this timeline slider. So again, the slider is a built-in component, and that is going to handle all the events where we slide the slider left and right, which is going to scrub through the timeline and seek the main video to that particular frame of animation. So all we need to do is to say what functions do we want to call when certain actions are performed on that slider. And we've got 3 different events that we want the event handler to respond to. We've got pointed down. So this is when the user initially presses down on the slider control here. We've got pointer up, which is when they release control. So it's either with the mouse cursor or with their finger if it's a touch device. And then we've got on value changed, and this is going to be called repeatedly as the slider is moved left and right, and this is going to call a function here which is going to move the video to the corresponding frame location. So that's it for the layout of the screen. Like I say, I chose this slightly arbitrarily, based on what I thought a CCTV monitoring app should look like, but you can really change this how you want. You don't have to have these controls at all. If you don't want the player to be able to scrub through the frame, we can select bottom panel here, and we can simply remove it from the scene completely. And then having done that, well, let's maybe decide that we want our video to be a little bit higher. So we could change this to be 1280 instead. Oh no, that's way too big, isn't it? Something like that. And you can move it round. Let's say that instead of having just simple text on our playback control here, we want to have some icons instead. Well, that's fine. We can find them in the hierarchy here. And if I right click and go to UI and add an image, let's say, and then in my texture at the bottom here, so as well as having my render textures, which were dynamic images, I've also just got some icons here which I drew, and these are just simple ping files. So let's say my play button, I want to have a play button on it instead. And I come to my pause button, I'll do the same. So I go UI, image, and then let's put my pause icon there. And now I've got kind of a graphical interface instead. Well, in fact, it happens I've still got the text. So let's turn the text off underneath like that instead. That's a bit prettier. So I could mess around for ages kind of tweaking exactly how this looks and feels, but hopefully that's given you an idea of how this scene is constructed at least. If you want to know more about laying out elements in Unity, there's lots of great tutorial videos on YouTube. Nothing that I've shown you here is anything specific to this application at all. Adding components to the scene, assigning scripts and things like that, that's all kind of fundamental Unity behavior. So there's lots of resources there if you'd like to know more. But in terms of this particular project, what we need to do next is now to look at those scripts that we assigned that were calling the controller. So we've got our buttons here that we're calling a function called setSource, and we've got our play button that was calling play and pause, and then we also had the slider at the bottom which I turned off, and let's get that back, and that was calling on scrubber value change, control down and control up, and these are all calling a single script which is called controller, and that's assigned to the main camera up here. So to show you what all those functions do, I can now just double click that script and it will load in Visual Studio. So let's have a look through that. Okay, so Unity scripts are written in C#. Now, if you're familiar with Arduino coding, that's written in C or C++. So it's got a slightly different syntax, but hopefully you'll still be able to recognize the basic structure of how this is set up. And, I tried to keep my C# scripts arranged in much the same way as I would do in an Arduino project anyway, so hopefully there'll be some familiarity here. So we start at the top of the code with declaration of effectively global variables. In an Arduino script I would define things like the constant values which define pins which sensors might be connected to and things like that. What we're going to do here is we assign some public variables that correspond to values that we want to be exposed in the inspector here. So we want an array of video clips that correspond to each of the different sources that we're going to play on our cameras here. We want a reference to the main video player itself, that's the one that's going to be on the left hand frame here, and also to each of the small video players that we're going to have on the right hand side here as well. And we also need to grab a reference to the slider control that was at the bottom here. So when we declare these at the top of our script as public variables like this, what it means is that they're going to appear in the Unity editor window, and you can drag things into them. So I've already assigned all these components here, but let's say I wanted to change one of these video clips. What I could do is come to my video clips project window at the bottom, and I could simply drag a new clip into element 0. So now what's going to happen is both of my top two cameras are actually going to be displaying the same video feed, which is video feed number 2. Obviously I don't want that, so I'll just replace that again with number 1. And you can either drag resources from your folders at the bottom. So these are kind of assets in your project. Or you can assign elements from the scene itself. So the timeline slider here, well, this is actually an object in the scene. It's this one here. So I'll drag that into the timeline slider slot. Timeline slider slot. Crikey, that's hard to say. And that means that from now on, I can refer to timeline slider in my code. That is going to be hard to say. And it will refer to this particular slider that exists in the scene. Okay. Now we've also got some private variables. So these are going to just be used within this code to keep track of certain behavior. So we need to keep track of whether the user is currently dragging the scrub control, the slider left and right. And the reason we do that is because while they're scrubbing, we don't want to also be playing the video at the same time. We'll kind of pause the video for the duration which they're holding the slider down, and then when they release it, we'll start it playing again. I've also got a variable here called lock. Now this was to do with the fact that when you seek to a particular frame at some point in the future or in the back of the video, there's a short amount of time where it has to buffer the frames of where you've jumped to. And what I was finding is that if you were jumping around the timeline a lot, so if you were dragging the slider left and right, left and right, left, right, the different video sources were becoming a bit out of sync with each other, basically. So the way I fixed that was to put this lock variable in here. And what this does is it doesn't let you drag the timeline again until it has fully seeked the last instruction. In fact, all the videos are synced, and I find that that helped prevent things getting out of time. That's kind of a fix for that. That's what that was for. The last one is a variable that says was playing. So this all relates to the scrub control still. Let's say you paused the video first and then you move the scrub control. When you let go of it again, you'll still want the video to be paused. Whereas if you were playing and then you drag the scrub control, when you let go, you want it to resume playing. Now, because I mentioned that we were going to pause the video either way when we're scrubbing, we need to keep track of whether it was playing or not before. So that's what this variable does here. So then we go on to start. I'm just going to increase the size of my font so you can read my text a bit more easily. So start is much the same as the setup function in Arduino code. It gets executed once on startup. And what we do here is we'll just do some initial configuration. So this is what's called a callback. And again, this relates to this idea of scrubbing left and right in the timeline. Has to be said, if you don't want to use this feature, by the way, if you don't want to scrub left and right, this code could be made substantially simpler, because a lot of the extra lines of code I had to add in here were relating to that timeline functionality. That actually took a little bit of experimentation and iterations to get that working correctly. So if you don't want to do that, then this code becomes a lot easier. But what this does is this fires a function called video seek completed, which we define a little bit further down there. And it does that whenever a seek action, so when a new frame is requested at some point in the future or past, when that operation is complete, it calls this callback here. And this all relates to this idea of preventing synchronization issues again. Basically, I want to know when the last seek was completed before I let the user do a new one. And then what we've got here is we've got some initial assignment of clips to the correct video players. So video player.clip, well, that is the clip assigned to our main window here. And then we've got our array of thumbnail video clips, and we're going to assign to each one of those the video clips from the array here. So we've got an array of 4 video players, and we've got an array of 4 clips, and we're going to assign each one to the corresponding video player when the application first starts. So again, that's why it doesn't matter that we've got something here that says missing video clip. because that's going to get overridden in the very first frame of the application anyway. Okay, that's the end of start. And then we go on to our different methods of the different buttons. And the first button, or the first control we're going to look at, is that scrub control at the bottom. And remember, that had 3 different events assigned to it that we wanted the event handler to respond to. The first one was when you pressed down, or so either with the mouse cursor or with your finger on the scrub control. And when you do that, we'll update that variable at the top of the code that lets us keep track of whether we're currently scrubbing or not. We'll also keep track of, at the point that the person started dragging the slider, was the video playing at that point or not? And we'll assign that to was playing. And then while the scrub control is being dragged left and right, we're going to keep the video paused for the duration of that movement, just so we're not trying to get the player control to load a new frame, and also for Unity to be trying to advance the frame just over the passage of time as well, because that would cause issues if they were both trying to set different frames at the same time. So we'll pause the video while it's being scrubbed, and we will also pause each of the thumbnail players as well on this side as well. So everything pauses while this controller, or when you press down on this controller, everything pauses basically. That's what scrub control down was. Scrub control up, well, that's what happens when your finger or mouse cursor is released from that scrubber at the bottom. So this is no longer true. We'll set that to be false. And then what we need to do is we need to reset the state of the player that it was in at the point that scrubbing started. So if was playing is true, that was set when we pressed our finger down here based on whether the video is playing at the time. And if that's the case, we then want to play all of the clips again. So this is the main video player window, and this is each of the thumbnail video players window. If this wasn't true, then we don't want to restart. We can keep them paused, but we don't need to explicitly call pause to do that, because they were paused up here when scrubbing started anyway, so we just don't have to do anything in that case. Alright, so that's down and up. And then this is the slightly more complicated function probably, because this is called repeatedly as that slider time scrubber control is dragged left and right along the video frame. This is going to set each of the video player frame values based on the position that the slider was dragged to. Okay, so this is called repeatedly, and it gets past a value here, which is a float value. And what that floating point value represents is the proportion along this timeline that the slider was dragged. So if I go just to the slider control for a moment here, and when we look at the parameters on the slider script that's assigned to it, you'll see it says the minimum value is 0 and the maximum value is 1. So what we're going to get here is a fractional value, and in fact if I drag this up and down, so you can see if I get it to about 0.5, that's in the middle of the line. 0.25 is somewhere around there, which is a quarter, exactly. So this ranges in decimal points from 0 to 1, and it's going to be a proportion of the way through the video clip. That's what that number is going to represent. So then what we need to do is we need to work out, well, what does that correspond to in terms of frames of that video clip? So what we need to do is we need to multiply the fraction of the way through the video we are by the total number of frames in the video clip that we're playing at the moment. That's given by frame count, and that will give us the index of the frame that we want to seek to. Now we only want to do this, however, if the lock variable is not currently set to true, because lock was set at the lock was defined, sorry, at the top of the screen. Remember I said this helps prevent synchronization issues of the different video players getting out of sync with each other when you scrub around lots and lots. So only if the value is not currently locked, we're going to work out the frame that we want to jump to, and then we're going to start this coroutine called seek video at frame, and we're going to pass it the frame index. So now I'm going to have to explain what coroutines are. So notice up to now we've been using functions. So we've got public void, we've got void start up here. So this is a function that does not return any value. This one doesn't have any parameters. This one is a public function that doesn't return any value, and it does have a single parameter, sorry. And here we've got what's called a coroutine. Now, this relates to the fact, this is a little bit like in Arduino code, if you wanted to make an LED blink, you might be familiar with the idea of not wanting to use delay. So in a very simple Arduino code, if you're familiar with that, what you might do is light an LED and then delay for 1000 milliseconds and then turn the LED off, delay for 1000 milliseconds, turn the LED back on again. And that would be a way to get an LED to blink once every second, for example. The problem with doing that is that in the delay function, what you're telling the code is to wait for a second, and literally everything waits for a second, the entire execution of all your code. So if you are also waiting to see if a button was pressed in that time, or if any data had been received over the serial connection, or if you wanted to print a message, anything like that, none of that would happen in the time when you were waiting to change the LED to its next state again, because you'd literally told the code to delay. And it's a little bit like that in Unity as well. All these regular functions here, when you call a particular function there, if you tell it to do instruct a line of code, it will wait until that line is completed before it moves on to the next line, and then it will wait for the next line to go on to that. So these are all operating on a single thread, one after another in series. Now, when you load a new video, however, or when you seek to a frame of a video, as I mentioned before, that can actually take a little bit of time to buffer all the frames, and we don't want that delay to hold up everything else in the code. So if we just directly, in this, when the scrubber value is changed here, if we just calculated the new frame that we wanted to go to based on the fraction of the way through the entire count of the frames, if we just set the video to that new frame in this method here, what would happen is the code would become incredibly sort of jerky, because it would have to wait for all of the videos, not just the main one, but all the thumbnail videos as well, to update to that new value before continuing. And in the meantime, nothing would respond to the mouse cursor, nothing else would update, no buttons would be detected or anything like that. And we don't want that to happen. So we use what's called a coroutine instead. And a coroutine is a really good way of having any kind of function that might take a long time to return, but while you want other stuff to be carrying on in the meantime. It's a little bit like a separate thread. It's not actually a separate thread. It still runs on the main thread. But what it means is that we can call this coroutine here, seek video at frame. We'll set the lock value because we don't want another seek to start until this one has finished happening. We will attempt to set the video player to the requested frame, and we will also set all the other thumbnail videos to the requested frame as well. But this is not going to pause execution of anything else that's happening because it's happening in this coroutine. So again, that's relatively complex kind of code structure there. Even if you are familiar with using Unity, you might not have used coroutines in the past. They're very, very powerful, and they're hugely useful in terms of making responsive applications, but they are a little bit more complicated. But I just want to explain why I've done it like that. And what what happens then? So this sort of seek can happen in the background nearly, and when it's completed, that's what fires this function here. So we assigned this callback in the start method here. We said when a seek is completed, we want to call this handler video seek completed, and that is what releases the lock. Okay, so we've got this is being called continuously every time that time slider is moved left and right, but only if the lock is currently available. It works out the frame to jump to. It starts this coroutine. The coroutine is what sets the lock to be engaged, and it's only when the callback says that the video has successfully completed the request frame, that's what releases the lock. Okay, so that is the most complex bit of code in this entire project. Okay, so if you understood that, you have cracked this completely. You have got the whole thing. And like I say, if it weren't for the fact that I decided to put this timeline slider in, I could have skipped out that whole section and this project would have become a lot more simpler. But I wanted to leave it in because I think that's something that people might want to be able to do. But that's why it's there. Okay. Like I say, that's probably the most complicated bit. Now what we need to do is look at the functions for switching the camera feed and also the play and the pause buttons. So let's have a look for those. So pause, this is nice and straightforward. We call the pause method. It calls pause on the main video player window and also on each of the little thumbnail source on the right hand side. And we've got a play button above it. That does exactly the same thing. It calls play on the main video window, and it also plays each of the individual thumbnails. That was easy, wasn't it? Okay, which now means we just need to think about the set source function. So this is the function that was called when you press on the different camera buttons here, and remember they all call the same function called set source, but they provide it a different parameter value here, 0, 1, 2 or 3, corresponding to which feed it is that we want to then display in the main window over here. Okay, so this is the function they call, and this is source number, which is that parameter they pass. As when we're scrubbing, what we want to do is we want to keep track of whether the video was playing at the time that this source was changed, and we also want to keep a record of what the current timestamp was in the video that's being played at the moment, because when we load a new clip into that window, by default it's going to load it starting from the first frame again. So when we swap the clip over, what we're going to need to do is to restore what the timestamp was just before we change the source over. So we'll store that in a variable there, which we'll call current time. Then what we'll do is we'll swap the clips over to whatever the requested clip was. So when we clicked on the top button, source number was 0. So that will load the first element from the video clips array. And remember, the video clips array was what we have over here. So the element 0 is the first element of the video clips array. That corresponds to movie clip 1. And that was the feed that was going to camera 1 there. And if it's 1, 1, 2 or 3, that will correspond to the second, third and fourth clip as well. Having loaded the new clip, we will do this await until it's prepared. Again, we're doing this in a coroutine, so we can let other actions in the code carry on running in the background while we wait for this new video clip to be loaded in, for the frames to be buffered and all ready and things like that. And when it is prepared, we'll carry on. And what we'll do then is we'll restore the time that we kept a note of here just before we changed the source. So this was the time that the previous video clip had got to. Then we loaded the new clip, and then when the new clip is ready, we'll set its time to be equal to whatever the time was in the previous video. Now this does assume, I should point out, that all of the sources of your different video clips have the same length of video in all of them. That is kind of an assumption in the way that I've written the code here. If they don't, what's going to happen is that things like the amount of time through the clip is going to be a different fraction on each of them, and the scrubbing and also the looping back to the beginning when a clip is finished playing, that's not going to work very well. So I have assumed here that all of the video sources, as of course it would be in a genuine CCTV camera footage, if you're looking at the same scene over an hour-long period from 4 different camera angles, you've still got an hour's worth of footage in every camera. So that is an assumption I've made. But I'll show you in a moment how I prepared my videos to be the same length. So I'll get onto that as well. Now, this is also another little bit of a sort of a workaround fix that I found that I needed to do. So having loaded the new clip, I found that the screen didn't actually refresh until I'd played at least one frame of the newly loaded clip. So even if the video was paused when we changed the source, I want to play it for at least one frame just to make sure that the screen updates with the new video clip in place before I pause it again. So I'm going to play it regardless of whether the video is paused or not. Yield return null will mean that this function or this coroutine will wait for one frame before continuing, and only here am I then going to pause it if it wasn't playing before. So yeah, I found that this was necessary just to make sure that the screen actually updated properly. Otherwise, what happened, if the clip was paused when you changed the source, it swaps into the new source, but because it's paused, it never actually shows it until you start playing again. So that's what that was for. And then finally, this is the very last function. We're nearly there. So this is the update function, and update is akin to the loop function in Arduino code language. So update gets called over and over again every frame that the application is running. And this section here, what this does is that this makes sure that while the video is playing, the slider at the bottom here is updated to, it moves through the timeline to keep progress with the video as it plays. So what we need to do is this only gets called if the video is playing. This only gets called if the user is not currently scrubbing the video, because if they're doing that, they're moving the slider manually themselves anyway. And also it only wants to get called if the number of frames in the video player is greater than or equal to 0. So when a new source clip was being assigned here, there's a brief moment of time when you swapped clips that the new frames have not been fully loaded yet. And what I was finding is if you were updating this here without that additional condition there, the timeline slider was jumping around a bit as you loaded a new video, because it hadn't yet counted all the way to the number of frames in the end of the video. So I'm only going to update the slider with the position through the video clip once I know that all the frames have been loaded. That's what's there for. And what we'll do is we'll set the value of the slider to be the fraction of the time that we are through the entire length of the video clip. So if we're 30 seconds into a 60-second video clip, we'll set that to be 0.5 because that's halfway through. And that will adapt, whatever length video clip you choose to use, whether you want an hour, 5 minutes, whatever. This will adapt fine because it will just use the length of the video clip you have assigned and the amount of time that it is currently through it. And then finally, I've just got 4 controls at the bottom here, and what this does is this actually provides keyboard input as well. So up to now I've been assuming that you've been using either a mouse control to click on these buttons here, or if this is deployed to a tablet or a phone, this would be touch controls instead. But maybe you want to have it so that you have a keyboard interface as well, and you can get a nice particularly think about using this in a real life escape room. You don't necessarily want to give players, a mouse where they can click on anywhere on the screen. You want to kind of limit the interactions they can have. So you could have one of those a separate numpad keyboard that just has the numbers 1, 2, 3, 4, or however many different cameras you want to use and to switch between them. And you just press the key corresponding to the camera source you want to switch to. Well, that's what these lines of code does here. So we will listen for a key down. So this means that a key has been pressed down on a keyboard. Which key has been pressed down? Well, I'm listening to the number keys 1, 2, 3, and 4 on the alpha section of the keyboard. So these are the numbers across the top row of the keyboard. But if you wanted to change to anything else, so if you wanted this to be a letter key like A, or a joystick key we've got there, it could be a button on the keypad, or left shift, whatever you wanted it to do. Basically any key on the keyboard somewhere you could map to a function here instead. And what do we want to happen when you press that key? Well, we want these keyboards here to change the source to the first, second, third, or fourth camera feed. And like I say, if you wanted to add a new line that also added play and pause functionality, for example, we could say if input.get key down, I don't know, what could we make be play? Let's make the space key, for example. We could make that call the play function. So we could just call it like that, and then you could add one for the pause and everything else as well. So that's just an additional way to control the script. And that is the only code that I actually wrote in this entire project. Everything else, all of the behavior of the video clips and the buttons and the slider is all built using inbuilt Unity components. So I just want to explain briefly how I prepared the video clips which I used in the demonstration at the start of this video. And to do that, I'm using a program called Shotcut, which is a free open source video editor which you can download from the web. And I mentioned that the Unity project expects all of your camera feeds to be video clips of the same length. So you see what I've got here is I've got 4 video tracks on my timeline, and I've cut them to all be the same endpoint here, which is an arbitrary timestamp of 2 minutes and 23 seconds. That's just how long it took me to record my intro video here. And if you've got 4 video cameras, or however many separate cameras you want there to be feeds for, obviously you can record them all in one take in real time. But I didn't actually have that, so I've kind of had to bluff here. What you'll notice in my first track here, I've actually got a PNG file, which is just a static screenshot, which I've inserted between the video clip here, where I exit the room, and then for all these frames here I'm just playing exactly the same static file, and then as I enter again I've got a new video clip here. And I've done that on the other tracks as well. You can see I've mixed video clips with image files, and that's just how I made sure that all of the videos lined up as I wanted them to within the complete timeline. Now to actually check they did that, there's a lot of video filters you can apply in Shotcut. So the timestamp and the little kind of camera kind of text label which I've put here, these are applied as filters which you can just turn off and on. So the timer, you can set automatically the format for the time, an offset, so I've set that my time starts at 11:23 in the morning and is going to count up for 3 minutes. Again, you can change that to any time you want, and kind of that will bake it onto the video as it were when it's exported. And I've also got a camera 1 on each of my other video tracks. If I turn this layer off, you'll see that on camera 2 I've got a filter, and all I've done is just edited the text here to say camera 2 instead. When I turn this one off, you'll be able to see camera 3. Now at the moment, because of the way the timelines are all stacked on top of each other, you're actually only able to see the topmost video at any one time. If I turn these back on, they'll get in the way. So to make sure that everything lined up, what I actually did was apply another filter, which is this size and position filter. And on my top video, I just shrunk that video down and placed it in the top left-hand corner. And then my camera 2, I moved to the top right-hand corner. My camera 3 to the bottom left, and my camera 4 to the bottom right. And this was just so that I could preview them here to make sure that they lined up correctly. As I walked out the door, I was seeing at the same time, because like I say, these weren't actually all shot in one go, they were shot separately, and then I just wanted to line them up to make it appear that they'd all been shot simultaneously on 4 different camera feeds. And I padded the space in between with these images, as I mentioned. And you can apply lots of other effects here as well. You can apply audio effects and you can apply video effects. So let's say we wanted to make this look more like a traditional CCTV camera feed. Well, they're probably going to be in black and white. You can turn down the saturation, for example, by applying a saturation filter here. If I turn the level down, you'll see that my top image here, my video preview of my top track has gone black and white. Perhaps we want to pixelate it as well slightly, so we can apply a mosaic effect. That's probably a little bit excessive mosaic. Let's take that down slightly. We've now got sort of more like a simulation of a low quality CCTV feed. So it's really powerful software. And then when you've got your 4 feeds correctly set up as you want to, what I simply did was to export each one as 4 separate video files and brought them into my Unity project. So I hope this video has given you some ideas and also information about the tools you can use to create a CCTV based app for use in an escape room game, and that runs on a PC or a tablet or even on a mobile phone. And I'll put links in the description below to Shotcut and to Unity, which are the 2 software applications I used. As I mentioned, they're completely free to download, so definitely do go and try them out. And you can either follow the steps which I described in this video, or else, come up with your own app that uses these videos in a different way. One thing I didn't mention is it's possible to actually incorporate live feeds as well as pre-recorded feeds, and that can add a whole nother level of immersion to the players if they're able to see themselves in the room on one of the camera feeds. Now, I'll also upload the Unity project files which I used over onto my Patreon account. You can access all of the downloads, all of the code and all of the wiring diagrams of this and all my previous escape room projects from this channel over on my Patreon page. I'll put a link to that as well. I'm only able to make these tutorials with the support of my incredibly generous Patreon donors, so as always I want to thank you all very much for letting me do this. And if you have any comments or questions about this project, please do write them in the comments below and I will do my best to get back to you. Otherwise, I hope you have fun playing with this project and I look forward to seeing you next time. Okay, cheers, bye.